Alrighty, I think we'll get started here. I assume everyone can hear me. Yeah, thank you, and welcome to the first Dagster community meeting. We're planning on making this a monthly affair. We want to keep it pretty lightweight. For today, we actually have quite a bit of prepared content, but as we go on, we want to make this more kind of community-driven, lightweight. So we just kind of give updates on what's going on. We can get feedback from you and answer any questions for everyone. We're also interested in getting more kind of community-created content. So if you're interested in speaking or want to share what you've been working on, please feel free to do so. So everyone can see I'm doing an old school slide. So using my whiteboard here, it's the second Tuesday of every month. And then today's agenda here, we're going to have Max go over kind of what we worked on for 090, what we think are relevant features for you. Also, feel free to give, and we'll have Q&A at the end. And then Sandy is also going to talk about our plans for 010, which, we're doing these kind of major releases every few months. So we're targeting that to mid-November. And then Tomas from Prezi is going to talk about how they're using Dagster at Prezi and using it at scale on Kubernetes. And then we'll wrap it up and have time for QA. So that's the agenda today. Oh, by the way, I should probably introduce myself. I'm Nick Schrock. I'm the founder of Elemental. And yeah, thank you all for coming and for being users. Or if you're not users, thank you for coming anyway. And with that, I will hand it off to Max, who's going to talk about relevant features from 090 and what we've been working on the last couple months.
Hi, everybody. Thank you for coming. My name is Max. I'm an engineer at Elemental, and I want to talk a little bit about 090 and what we did, and introduce some of the new features. So our 090 release, codenamed Laundry Service, was a shorter release than 080 before it or than 010 after it is going to be. We focused on cleanup and hardening. I think that we should mention at the top level that we've officially dropped support for Python 3.5 for two reasons. No one in the community was using it, and supporting 3.5 was actually more work than supporting Python 2. So we've also added full support for Python 3.8, which is largely thanks to PySpark finally being 3.8 compatible. And I want to shout out to all of our community contributors. Thank you so much. These contributions are ramping up. If you would like to contribute, please let us know, and we can help you do that, make it easier for your contributions back to the code base to merge. So I want to start with some of the sort of internal work that we did in 090. The biggest thing is much better user code isolation. So the broad overview here is we'd really like it if user code, like the code inside a solid definition or inside a resource init function, could not crash the framework, could not crash Dagit, even if it said false. And so what we've done is we've isolated user code at the process level. And now all the code that you write in like a solid definition or any other function that's executed by the framework is executed in a separate process. And that process communicates with the framework over gRPC for interprocess communication. So this is pretty exciting. It makes operating the framework much more robust. It also opens the door to a couple of cool infrastructural things that are coming down the pipe, or in some cases already here. The first of which is executing user process in containers, executing user code in containers. So that's something that is already present on master and you can start playing with. The containers will communicate with the framework over gRPC. In the future, there's the possibility to do sort of more extravagant things like write Dagster native code in other languages. For instance, you could have a Scala solid, but as long as it communicated over gRPC with the same protocol, it would still be possible to execute that user code alongside the Python code that you expect. So that's a pretty neat internal change that's going to enable a bunch of features coming down the pipe. We also did a lot of work to harden the Kubernetes deploy strategy, not because Kubernetes is the blessed or only way to deploy Dagster, but because we think it's important that people be able to deploy in a robust way in Kubernetes. So that starts with a bunch of small improvements and bug fixes. The Helm deploy is much more flexible. The scheduling is much more stable. We've also implemented run termination on Kubernetes. So if you have a run that you wish to interrupt that's running on Kubernetes deploy, that is now possible. We're building towards seamless, no downtime user code deploys. Some of that has already landed and some of that is coming in 0.10, and I think Sandy will talk a little bit more about that. And we've also separated out some of the code into separate packages. So previously we had a little bit of a, concerns were a little bit mushed together between Dagster Celery, that is using Celery as a run queue, using Celery to launch user code in separate containers, and the Kubernetes specific stuff, and that has all been separated out. So now there should be a cleaner sort of dependency management story between your Kubernetes deploy if you have one, your Celery deploy if you have one. We also did a bunch of work on the scheduler to make it a little bit more robust. There are some bug fixes there and stuff, but the big change and the thing that we're going to be building on the most going forward is the new instance-wide view of the scheduler in Dagit that lets you review all of the schedules that are running and all of the historical runs that are associated with them. And there's a bunch of stuff that's going to come down the pipe in 0.10 that's pretty neat on top of that, including specialized UIs for backfill, longitudinal views of your past schedules and partitions and so forth. We also have introduced support for Kubernetes native cron. So if you're running on Kubernetes, you no longer need to use system cron. I want to talk about two sort of user-facing API changes as well that we think are pretty exciting. The first of these is experimental. It's hooks. We've had a lot of demand for the ability to run arbitrary code on solid success or failure. And so hooks is a way of doing that. So here's an example of writing little hooks that on failure or success of a solid send some message to Slack. And hooks like this can be attached either to pipelines or to specific solid invocations inside of a pipeline. So this is still an experimental API. It's very much in flux. We really appreciate you playing around with it and letting us know how or if the API needs to change. I'm very excited to see what people do with this. I think it's going to be very powerful. And the second feature I want to talk about is the sort of configured wrapper. So this is a very flexible idea, but basically if you take some configurable object like a solid, you may have chunks of config that you really don't want to repeat every time that that solid is invoked. You want to package the config up with the object. Same for resources and the other configurable objects in the Dagster API. So what configured lets you do is exactly that. You can take some solid and some chunk of config, package them together, and then that basically constitutes a new solid definition that you can reuse, but that already has the config fragment packaged with it. And this is a very flexible idea. It also includes the possibility to have custom config functions, which take in some config specified on the configured object and then transform it to config that is valid for the wrapped object. So we think this is really going to enable a lot of code reuse and reduce the possibility for errors in like repeated config fragments. Again, very excited to see what everyone does with this API. New in 0.90, or rather newly committed to, we want to kind of formally express a deprecation policy. I talked about hooks as being experimental. That's part of what we're doing here. But we are formally committing to you guys not to break public APIs in minor releases. By public APIs, I mean everything that's at the top level in the Dagster package. So if you are seeing breakage in a public API between major releases, that's a bug, and please surface that to us because we're really serious about trying not to break you guys. We will mark APIs as deprecated before they're broken. We have new code level support for that. So when you use a deprecated API, you should get a warning print to the console. Please enable warnings in your test suites if they're not already enabled. That'll help you keep track of our plans to deprecate APIs. And we've introduced this experimental wrapper. When you use an experimental API, you'll also get a warning. APIs marked experimental, we do plan to be able to break. So that's how we're going to distinguish between things that we'd like the community to start experimenting with, but where we're not certain that the API is correct yet, and things that we're really committed to. As always, if you find yourself using internals to get meaningful work done, please get in touch. That's a sign that there's a missing public API, and we're very curious to know what you're trying to get around or what new functionality you found a way to implement. I want to briefly touch on a couple of notable public API changes in 0.90. These are mostly just renamings, and I know that they induce a degree of thrash. Thank you for putting up with it, but we think that it's going to make the platform much easier for new users to start using and easier for them to understand. So some of these are just renamings like config to config schema. We renamed materialization to asset materialization, in part to highlight that materializations are meant to play with the asset system. Some of them are sort of signposts of more thoroughgoing conceptual changes that are coming down the pipe. For instance, the system storage, which is I think a very difficult thing to understand and a difficult thing to build a custom system storage, is becoming an intermediate storage, and that's paving the way to changing slightly the way that it works with the internals so that it's easier to understand and easier to build them. Similarly, from engine to executor, we think that the role of the engine is going to change a little bit and eventually perhaps incorporate some of what is currently done by the run launcher, and calling it an executor is a little bit more true to that. And then there are some just terrible naming choices that we've changed, like input hydration config, which really is a barrier for someone trying to adopt a system. We're now calling that loader, which makes a lot more sense. But thank you for putting up with these. These are some of the things you'll have to grep for if you are migrating to 0.9.0. So thank you. If there are any questions about 0.9.0, I'm very happy to talk about it later at the end of everyone's presentations. And now I'll turn it over to Sandy to talk about what's all the exciting stuff that we're planning to do over the next couple months. Thank you so much.
Hello, give me 1 second. Okay, can you all see these slides? I'm gonna assume that's a yes. Oh no, I haven't even hit share yet. Really good at Zoom. Awesome. So my name is Sandy. I'm an engineer at Elemental, and I'm going to spend some time on what we're thinking about for our upcoming 0.10 release. For those of you who aren't familiar with Dagster's release cycle, we do a major release like 0.10 roughly once every 3 months. So what I'm going to be talking about here is the set of features we're thinking about roughly for November. We're not going to get to every one of these items, so don't interpret this as a concrete plan. Instead, it's a set of areas that we think are important, and we're talking about them because we want to understand on what you think is important, and then also what we're missing. So how do we decide what to work on? The first thing we asked ourselves was, what are the parts of our system that give our users the biggest headaches? There are some difficulties that come up over and over again in Slack questions, GitHub issues, and direct conversations with users. Some of these pains just require sanding down some rough edges with the docs, that others require bigger architectural changes to less mature parts of the system. The second thing we asked ourselves was, how can we push the envelope of an orchestration system? So what are the situations where the Dagster way of looking at things lets us offer some powerful capability that's maybe even beyond what our users would have expected? So these are opportunities to really double down on what's unique about Dagster and try to offer something really exciting. So where are these pains and opportunities located in the system? We think of Dagster in roughly 3 layers. The top layer is the world of data assets. So these are the data warehouse tables or machine learning models that we're actually building our pipelines to produce. The middle layer is the world of execution. So that is solids, pipelines. These are the set of primitives that Dagster actually uses for running stuff. And holding it all up is the world of deployment and instance management. 1 second. Everything that's required to keep to basically set up a production Dagster installation and keep it going. I just realized that my face is hidden. There we go. Here's me. So for each of these layers, I'm going to give an overview of the improvements that we're thinking about, and then maybe dive in deeper to a few of the interesting ones. So let's start with the assets layer. There are 2 big pains that we hear about at the assets layer. And the first one is backfills. So right now it's difficult to backfill over a subset of solids. It's difficult to track the status of a backfill, and it's unwieldy to manage large backfills that kick off jobs with tons and with like tens or hundreds of partitions. So basically we want to mature this whole experience. The second pain we hear about a lot is pipelines that write intermediate, so some sort of data warehouse or data lake. So many users express confusion about the relationship between the asset and intermediate concepts that we have in Dagster, but both of these concepts are representing data that's produced by Dagster pipelines, but they function in slightly different ways. So we think there's an opportunity to smooth out some of those wrinkles. And then our in our exciting opportunities bucket, the big thing we're thinking about is what we're calling version-based memoization, kind of a mouthful. But what this means is tracking the version of the code at each step in a pipeline, so then you can avoid rerunning steps whose outputs you already computed in a previous run. The same capability could actually also make backfills easier to manage. So talking about backfills for a minute, this is something that we actually added to Dagster recently, and we call it the Step-Partition matrix. For any partition run, you can find this view in Dagit. And we have, for the rows, the set of steps for that pipeline. And then for the columns, the set of partitions that pipeline has been run over. And then you can click on any particular partition and understand all of the runs that affected that partition in the past. So what this is really useful for is basically understanding where are the gaps, where did I have failures that made it so that certain steps were unable to run for certain prior partitions. So I can come in later, look at all the runs that affected those particular partitions, and then rerun ones that are likely to cause problems. Sorry, just catching up on my slides right here. There we go. Okay, so let me jump on a little bit in a little more detail into this version-based memoization stuff. Consider this simple pipeline. When you run it for the first time, each of the 4 steps is going to generate some data. Then you might make some changes to the compute function for the 3rd solid. When you want to try out these changes, it's kind of a waste of time and resources to rerun the solids that haven't changed. But most engineers will actually just end up rerunning the entire pipeline because it's difficult to track what's changed and what stayed the same. Ideally, we would only auto-run the set of steps that are actually stale, because those are the ones that we're sort of interested in the new results from. So the version-based memoization feature allows you to tag any solid with a version. The idea is that the version should stay the same as long as the solid's compute function stays the same. So if a solid has the same version as the same solid from a previous run, they're expected to produce the same outputs when provided with the same inputs. With these versions, Dagster can actually determine which steps are going to produce results that have already been produced and which are going to produce new results. And if you supply this used cache option, Dagster can decide which steps to run based on that determination. This is particularly useful if you're sort of in like a tight dev loop, where you're going back and forth between making changes to a pipeline and then rerunning that pipeline. Especially if, as is the case in most pipelines, changes that you make in one step have impacts on downstream changes, and you end up having to make changes to multiple steps to make sure everything works. Instead of rerunning the entire pipeline each iteration, you can simply rerun the stuff that has changed. Another place we talked about the versions can be helpful is managing backfills. So often we run backfills when we made a code change and there were a set of prior partitions that we generated with an old version of our code. So we can leverage that same step partition matrix view that we showed earlier in the flesh to give us an understanding of which partitions are stale after a code change. So in this little visualization, all of the yellow steps are stale because we've made a code change to the solids that generate those outputs. So let's talk a little bit about execution. At the execution layer, 2 of the areas that we hear a lot about are what we call dynamic orchestration and cross-stack dependencies. Dynamic orchestration refers to situations where, for example, someone wants to kick off a task for every file that's discovered in a directory. So right now, Dagster is limited because it requires users to specify a fixed set of tasks when they define a pipeline. The idea behind dynamic orchestration would be that they could actually determine how many parallel tasks to run at execution time based on information that's only available at execution time. Cross-stack dependencies are when 2 pipelines don't make sense to merge into a single pipeline, but the latter has maybe some data dependencies on the former, and we don't want to begin execution of the latter pipeline until the former pipeline is completed. In the exciting execution opportunities bucket, one, and this is a little bit more speculative, is multi-container orchestration. The idea here would be to enable users to assemble pipelines out of tasks that each live in their own containers. This could make it so that the set of dependencies for different tasks within a pipeline aren't tied to each other. So this is a little bit more speculative feature that we have to think about what it would look like to build, but could also be a very, very cool capability. And the second more speculative feature is what we call event-driven scheduling. And this refers to launching pipeline runs instead of at a fixed tick in response to external events, like maybe new data has landed in a storage bucket and we want to kick off a pipeline to process that data. So lastly, for the deployment layer, we don't have as many exciting new features, but it's maybe the most important area to address pain, because users have trouble managing their Dagster instances in production, and there's not a ton they can accomplish with Dagster at all. The main things we've heard in terms of difficulties in deployment are difficulties operating the scheduler, difficulties deploying on Kubernetes, and difficulties managing large numbers of pipeline runs. So I'm going to dive a tiny bit into what we've observed about the scheduler. We observed a couple of main challenges with Dagster's current scheduler. So first of all is the fact that it depends on cron for the actual scheduling. This creates kind of a split brain scenario where you have to manage both the Dagster process that's managing the cron process and then cron itself. The second one is sort of a availability concern where node failures can actually make the scheduler miss ticks. So, while the scheduler node is down, it won't be launching any ticks. And when it comes back up, it doesn't know that it missed those ticks. We think that the best way to address both of these is by making the scheduler a first-class component of Dagster itself. So instead of sort of trying to outsource it to cron, we want to build the scheduler into Dagster because scheduling is so important to what Dagster does. So this will both make operating the scheduler easier, and it'll also enable us to build a fault-tolerant scheduler, or that when it comes back up after a node failure, it can cache up with these ticks that it's missed. So that's what I had for you so far. We're really interested in hearing from you what's important of the things that we talked about, and then what we're missing.
Great. Thanks, Sandy, and thanks, Max, for putting that together. Yeah, there's a ton of exciting stuff going on, and yeah, it's going to be great. I think O10.0 is going to be pretty epic, actually. In terms of things to, I highly encourage everyone to play with both hooks and configured, especially. I think it solves a lot of common issues that a lot of people, mention, and I think it can pay enormous dividends. Like, for example, with configured, if you have tons of repeated blocks of config in your config files that never change between runs, highly encourage you to look at configured to kind of capture that in code, and it kind of makes everything simpler. And then I'm personally really, this version-based memoization stuff is going to be incredible. So both for dev loops and for backfills. So it's great stuff. Next on tap is Tomas. So Tomas is a staff engineer at Prezi. They've been working with Dagster since effectively the beginning of the year, migrating their existing entire production system to Dagster. And they've been unbelievable partners through this. And if any of you are using the Kubernetes infrastructure, you have Tomas and crew to thank for grinding out a lot of the rough edges before you had to. And so we are all personally indebted to Tomas and crew. So without further ado, I will hand it off to Tomas to both show off the features of Prezi itself in his presentation, as well as explain the data infrastructure behind it.
Yeah, hi, thanks for the nice words. I'm super happy to be here and showing you what we did in this Dagster world and what's our journey to getting to Dagster and migrating to Dagster at Prezi. So let's start how we started. I think the data engineering and the data team started around like 8 years ago at Prezi. We started I think most of the companies, where we have a bunch of shell script and scheduled with cron. Of course, at some point, as the ETL jobs started to grow, we basically we figured out that it won't scale, so we had to come up with some kind of solution on that. It was like 6 years ago. We were looking around on the open source world, what other tools there are, what we can use, and to be honest, we couldn't find a orchestration which would work for us. So that's why we decided, okay, let's build our own one. We call this Flowkeeper. That's what you can see on the screen. This is our homegrown orchestrator. And one of the main design decisions why we decided to create a new one and not going some existing one is simplicity. So one of the requirements from our users was basically to not, they did not want it to write code to have a pipeline. And that's why we come up with a new orchestrator where we had a JSON-based config. If you wanted to create a ETL job or for our orchestrator, the only thing you have to do is basically creating a JSON file, and that's it. And I will show you how it looked like. Basically, this is a pretty simple JSON descriptor, what you can see here, where you can basically define the scheduling type. We have two types, is daily and hourly schedule. You can define the inputs, what your job is using. And also you can, as you can see there, you can give some kind of friendly name, and there is a pass what you can define. In this case, this is an S3 pass, what we pass. And also you could define what kind of data sets your job will generate. So in this case, this job input is some kind of S3 location, and then it will produce some kind of Redshift table. And when and you should know that, so these input and outputs is really we use this to build up the whole dependency graph in our orchestration. And we did not go with that concept, what you can see somewhere else, or like other orchestrator, where you can just basically define your job names, and that's the way how you define dependencies between the two jobs. Here we basically went in the past that you only have to know what kind of data sets you want to work with, and based on that we will figure out the dependencies and which job it needs to be connected. So basically, if you define, if you said that your input is this S3 location, what you can see here, and we saw that the other jobs generated the same S3 location, we connected the two jobs. Basically, this was or how we set up the dependencies between these jobs. I think it's pretty simple, and it's worked for us because usually the user knows what they are working on with, what kind of data sets, but they are not really aware of which job generates that. And we defined a couple of predefined job types. These are what you could use. And we here in this example is a Redshift load. Basically what it does, you specify input, and we load the input data into Redshift with the parameters what you can see down there. And we have a few job types like Redshift load, Redshift transform, which was basically running a SQL script, and we have Spark jobs and like Python jobs and a few others. And we also defined the tiers. So every data set put in some kind of tier, which basically is the priority. What does it mean? You can imagine that you have a bunch of data sets, especially if you have like hundreds of data sets, then it can happen then, and hundreds of ETL jobs, then it can happen that you have two jobs and two jobs can run at the same time. But like on the resource, what you want to run, there you can allow like running two in parallel. In that case, you have to make sure the more important data set will be ready earlier. And this is what tiers means here. The lower the tier, the jobs will be scheduled earlier if possible. And another thing what I failed to mention is basically the job type. And in the job type, this is a Redshift load, and job type also define the resource, what we are going to use. So in this case, Redshift, and even in our homegrown scheduler, we had these queue resource queues, where basically we made sure that you can't overload the resources, what the job is using. You can imagine, I guess, if you have like hundreds of jobs which can run in parallel, but if you would run these hundreds of jobs, heavy jobs on Redshift, that you most probably would kill that. So this was the state. This was our own scheduler, what we built, and we built some nice user-friendly UI, which is a pretty simple grid where you can see the jobs which was finished and what the status, and if something fails, you can see there as well. So things are looking good, and it seems like a user really liked it, and we ended up with a dependency graph like this. So we had around 900 jobs, and if you have 900 jobs, then you will face with a few issues. And that's why we were really thinking if we want to fix those in our current homegrown orchestrator, or we are looking for some open source alternatives. And why we decided to not improving our homegrown orchestrator. Basically, one thing is the maintenance overhead. So the data engineering team is a handful of people at Prezi. So we did not really have the capacity to fully focus on working on the orchestrator. Another thing is what you saw before this grid. So you can only see the actual job which fails, but you can't really see the dependencies between the jobs. So if you can't really see from that, if a job fails, then what other jobs were affected as well due to that failure. Another thing is this orchestrator currently running on one EC2 machine, and which if dies, then we are in the trouble. Then we have to start a new machine and setting up everything there. And also there are problems that because we are running all of our jobs in one machine, it can happen that two jobs interfere with each other. You can imagine if one job basically generates too high CPU load, or just eat up the disk space, or even worse, when basically you have some witty users and they just start expecting that they can write to a temporary folder and one job without defining that as a dependency between each other. One just put down some file there, and the other one expects to pick it up. And of course, the infrastructure at Prezi is moving to Kubernetes, so our data infrastructure needed to move as well to Kubernetes. Another thing was basically we wrote it like 6 years ago, and we had really not much time to work on that fully. It was really written in a not very extendable way, so it was hard to add new job types and etc. And the last one is with the lack of testing. We really missed that. So it's one. So if our users wanted to test our jobs, mostly they had to log into one machine, copying their file and trying it out from that specific machine. And we wanted to provide a way better user experience to them. And basically that was the time when we talked with the Dagster team, and they convinced us that let's try out their tool and try to and let's see how it works for us. And that's when we decided, okay, let's try to migrate to this new system. But of course, if you want to migrate to a new system, you don't want to write all of your ETL jobs from scratch. So what was our first requirement when we tried to move to Dagster is basically to being able to keep our descriptors and migrating and using it for generating solids in Dagster. So basically what we wanted, we had a car and we wanted to replace the engine, a way better engine and a way more reliable engine. And this is what we did. So keeping our job descriptors. First of all, we used our job descriptor and started to generate solids from it. How this looks like. First of all, we generated a solid config, which I now saw that it should be config schema, which basically, if you treat solid as a function which has parameters, then config is config are the parameters and its types. And as you can see here, we had the original JSON descriptor. What you can see down there, it's a Redshift transform, and we generated a nice schema, config schema for that. What you can see on the right side, this screenshot from Dagster. So as you can see, the type can be there, and for every descriptor, we generate one specific solid for it. So that's why it's so rigid. So here you can change Redshift transform any other types, because their inputs and even the processing wouldn't make sense. So there, as you can see, you can only specify Redshift transform, and you can and there are all the parameters which can be used in a Redshift transform. So in this case, like the SQL file, which basically says which SQL file needs to be run on Redshift when you're running this job. Of course, now you have a function and you have all the parameters. So you have a solid and the config schemas, but you need all the parameters or the values what you want to pass that. And these are the presets. We also generating the preset YAML from our JSON descriptor. Like if you check here on the right side, this one is generated one. The left side is basically one which is in our JSON. And as you can see there, we generated a nice preset where we say that where we pre-fill all the values what are in the JSON descriptor. And later on, if you want, of course, on the playground, you can change it if you want to run some test run. But basically, you don't have to do anything. We pre-fill it for you. Like in this example, you can see that this Redshift transform is pre-filled with the SQL file we want to load. We have the preset. Then we have the solid body. Basically, the solid body is predefined by us, and it's when it's get all the properties from the solid presets, and then based on that, we decide, okay, what kind of job types we need to run. So if it's a Redshift transform, then we will run a Redshift transform, and we do some other steps as well. So in a solid body, basically what we do is checking the inputs, doing the actual job execution. So in this case, like if it's a Redshift transform, they're running SQL on Redshift, and then validating output if it was generated or not, or if it's failed, etc. One more thing what we do as well, we are doing some kind of templating. So basically in the solid inputs, you can define in your SQL, you can say the friendly name of the input, and then we will replace the friendly name in your SQL with the actual table names. And now you have a nice solid, all the configs, the presets, and the body, but you have to define dependencies between the solids and what kind of dependencies, the input and outputs there are. And here we as well are using the JSON descriptor. And as you can see there, we are generating a typed input. So in this case, because it's a Redshift table, that's why we generate a Redshift flowkeeper pass. It's called in this example. And as well, we are generating for the second input, and also we generate the output. And when we are generating the dependency, basically what we do the same dependency setup, what I mentioned earlier, basically based on the inputs and outputs, output paths and table names, we look up which job generate that, and we do the connection between the solids based on that. And here you go. Here is a nice small pipeline defined. And last but not least, we also add some solid metadata, which not needed for the solid itself, but it's more like Dagster as an orchestrator, and also because we want to add some nice tagging onto these solids. So just a few examples here. When we set the max retries, basically this is what which says that how many times we want to retry a failing job before failing actually and stopping retrying. And also we set the tier here, and based on this tier, we also set the Dagster priority for the orchestrator. And also we set like the Dagster salary queue based on the job type, what I mentioned before for resource-based scheduling, or for the resource queues. So now we have a nice solid. We could do this for one specific job, but we wanted to make this migration the less painful. So basically transparent to our users. So let's give you an example. And we wanted to see our daily pipeline as one huge pipeline. That was one of the requirements from the beginning, what we want to achieve. Because what we saw, like other orchestrators, that they start to have problems if you have like hundreds of jobs or solids in one pipeline. And that's why you have to basically strip your pipeline into multiple pipelines and doing the connection between those pipelines. But the problem is that with usually most of these tools that you can't really see the connection between the pipelines. And that was one of the reasons why we really wanted to keep everything at one place and not basically being taking apart. And another thing, of course, that in the current state, we are not really able to do this because we have now 900 jobs and it would take a significant amount of time to do this. So what we did, we get all of the descriptors and load it into Dagster. And let me show you how this looks like. The whole pipeline loaded into Dagster. So as you can see, here's a huge graph. You can see it looks pretty nice, but it's not very useful in this way because you can't see much about that. As you can see, so it's very small everything. Even if you zoom there, it's very hard to find anything. But luckily down there is this nice selector where you can just select, sub-select of the pipeline, which can be super useful, especially if you try to understand your pipeline, or if you want to change some job and you are interested what other jobs can be affected with that change, or even if you are doing some kind of debugging where you are interested in if this job failed, what others can be affected. So I think it's a pretty cool thing. So now we have all of the jobs, and we can load into Dagster all of these, and we can generate from our jobs solids, and all of the solids can be loaded into Dagster. But another thing what we wanted to achieve, like the similar user experience what we have currently, or even better, here as well. And here is the workflow what we come up, how you develop your ETL, a new ETL job. So basically the workflow is the following. You as a user, you start working on your new shiny ETL job. You start a local development environment. Local development environment is basically Dagster running in Docker and locally. So, and there you can start working on your job, testing, and even you can go to access services with your own credential. When you are happy with your jobs, with your job, you have to create a pull request in GitHub. And then somebody reviews that. And in the meantime as well, Jenkins runs a check on this job. What we do, what we are actually checking, it's another, I think, pretty nice feature in Dagster that you can introduce modes as well. You can create multiple modes. And we introduce this test mode where, which actually not touching any of the resources, but what it does is just runs the whole pipeline and basically checks if there are circular dependencies, if there is any config issues, and if we are able to run the whole pipeline without running on actual resources, which is cool. If that's passed, then you can deploy. We are using the Kubernetes executor with Kubernetes salary executor. So what's happened in this case? So you have your job, basically these, in the end, what you do is basically just committing a JSON file into a repo. Based on that, we do a test run, and if everything is fine, then we create a Docker image from all of these descriptors and deploy it to Dagster as a user code separately. And then when you start or a new pipeline run schedules, then these jobs goes into salary and basically in the salary queue in various resource queues, like we defined a separate queue for Redshift, for Presto, and Hadoop, and Python. In Hadoop, that one where like Spark and jobs are running. And basically in this way, we can make sure that these queues, when a job is executing from the Redshift queues, then we can make sure that only like 5 parallel jobs is running. And it can't happen that you are overwhelming or Redshift cluster and no one else can be basically querying it, which is not a good thing if it would happen. And another benefit running on Kubernetes, all of these jobs are running in a separate pod, which is nice because jobs can't interfere with each other. If it's using too much memory, CPU, whatever, the pod got killed, but the other jobs can run, which is cool. And also another cool thing in the salary executor, that all this prioritization is there. So it's even treat or priority settings. Yeah, it's even treat or priority settings. And it's super nice, and we also got a few nice additional values using Dagster. One is this nice data lineage visualization, what I showed you before. The other one is this pipeline performance monitoring, which is pretty nice because most of the time, if it turns out you want to figure out if your pipeline is running slower than expected, and also then you are interested in why and which solid or job runs longer than before, because maybe there was some kind of change, somebody committed a change there which caused this, or maybe there is some issue with your Hadoop cluster or whatever. Another thing is like easier pipeline debugging. I think it's a pretty nice UI where you can basically see the logs immediately, and you have this nice filter as well, filtering down what you are, and here the solid selectors, where you can only see that portion of the pipeline what you are really interested in. And oops, sorry. And the testing capability, it's super nice. Actually, that's what I showed you in the GitHub example or the Jenkins example. So it's super cool, and we can make sure that we are letting way less garbage in with this running the whole pipeline in a test run. And of course, this nice type and config checking, which comes automatically. So if you go to the playground, as you can see, if you start specifying parameters based on the job type, it will hint you what you can use. And also you get some nice type checking. If, for example, this is external, should be a Boolean, but somebody started to type a string, then it will fail immediately, which is super nice. So this is where we are, and actually, but we are still working. So this migration is still in progress. So basically, we are now at 10%. So we migrated that 10% of all of our jobs. We are slowly migrating. We are basically migrating a few jobs, testing if it works fine, and then going back and trying to migrate more jobs. We need to do more extensive user testing and also onboarding all of our analysts. And in this way, we can basically speed up the migration, because we can create, and actually that's what we are currently working on, some kind of migration guide, which what we can hand over to them, and they can do on their own this type of, to migrate their own jobs. Improve backfill capabilities. I was super happy seeing that there will be a bunch of improvements around that. We really would like to see that. And yeah, this is something what we as well are working on to improve that. And introduce better quality checks. So currently, as I told you, quality checks is basically if there is a file or not, or if there is a table or not, or if there is at least one row in the table or not. But we would like to introduce more sophisticated quality checks as well later on. And last but not least, thank you, Dagster team. I think it's super nice, and I'll be really happy with the cooperation and all of these things, what you implemented. I think it's super nice. And we started to work on this almost a year ago, and where it was Dagster a year ago and where now, it's incredible where you get there. And I think you are like really in a ludicrous mode, so releasing new features. And well, yeah, that's it.
Yeah, thanks so much, Tomas. That was excellent. You guys have done a ton of interesting work, and thank you likewise for being great partners. And also for setting a new standard with presentation production values. That was an unreal journey through time and space. So we have to up our game, I think. Yeah, just wanted to open it up. We have about 5 minutes left, and wanted to open up for any questions. Feel free to either put it in the chat or to speak up. There's not too many people here, so I think we can manage it. And questions about 090 stuff, 010 plans, or anything that Tomas has worked on. Okay, looks like everyone's a bit shy. Wait a few more seconds. Okay, cool. Well, everyone feel free to, obviously we're in Slack all day, every day, so you can feel free to follow up. Oh, here we go. Regarding the version memoization, will this include changes in run config? Hugo, could you, do you maybe want to speak up? And it's a fairly generic question. I'm not sure exactly what types of run config changes.
Hi, can you hear me?
We can.
Yep. So the question essentially is, so you illustrated how, like using that feature, you'll be able to rerun pipelines and only rerun solids that have had any code changes. My question is, would that functionality also apply, say, if you changed configurations for solids down the pipeline? Would you be able to use that to kind of only rerun those solids which have had configuration changes? So like, does that make sense?
Yeah, it makes total sense.
Yeah.
Sandy, do you want to weigh in on that?
Hey, I'm sorry. Do you mind saying that one more time?
Sure. Oh. Yeah. So the question is, if you're updating, making code changes, like you'll be able to rerun the pipeline and only rerun solids that have had code changes, would that apply to making changes in the run config of solids down the pipeline?
Got it. Yeah, that's a great question. So the answer is yes. We would, the version for a particular solid would be based on, or for a particular step would be based on the version of the solid definition itself, and then it would be also based on all of the run config that affects that step. So configuration for that particular solid, and then configuration for any resources that solid depends on.
Okay, great. That sounds awesome. Thanks.
Cool. Thank you, Hugo. Yeah, and with that, thank you all for coming. And thank you for all the presenters. Tomas, you put an incredible amount of effort into that, so thank you very much. And then, you know, Sandy, Max, we're going to have to up our slide deck game, right? But both of you guys did a great job as well. So thanks to the whole team. And yeah, we're looking forward to producing all this stuff for you in the next few months. I think it's a lot of exciting stuff. So thank you all. And we will be posting this online as well.